Hi, welcome to ScopeGIS. In this video, we are diving into the basics with the question, what is GIS? So, Geographic Information Systems, or GIS as it's popularly called, is a powerful technology that allows us to visualize, analyze, and interpret spatial data. But what does that really mean? So, let's break it down. At its core, GIS is a framework and is used to gather, manage, and analyze data that is rooted in the science of geography. It integrates many data types and also analyzes spatial location and organizes layers of information into visualizations by using maps and apps and 3D scenes that are available within the GIS platform. And these visualizations tend to reveal deeper insights into data, such as patterns and relationships and the situations that they are involved in, thus helping users make smarter decisions. Right. So the components of GIS system, for any geographic information system to be called a system, an actual system, there are some core elements that need to be present. They are the hardware, that is the computer itself that is being used, the GPS, the server, and etc. The software, whether it's QGIS, ArcGIS, Google Earth, whether it's map info, and you also need data, spatial and attribute data. You also need the methods. What process is it going through? Is the data going through for you to be able to get any meaningful information out of it? Then finally, you actually need a human being who can actually work on and with the data. So whether it's an individual, whether it's a company, whether it's an organization, name it. And also, collaboration is where experts on or in a particular field come together to be able to effectively implement a GIS project. Right. So we move on to spatial data types and formats. What kind of data types does a GIS system accept? Well, there are two main types. There's a vector and the raster data type. And the vector data basically represents geographic features using points, lines, and polygons, whilst the raster is a more pictorial kind of data. So it uses grid cells to represent continuous data such as elevation, temperature, and name it. And some of the common file formats are shapefiles and GeoJSON for vector data and TIFF for raster data. Now, as I said earlier, any GIS system needs the method elements to be able to function properly. So the basic workflow of a typical GIS system is like this. You first go through the data collection where you compile and obtain the data you need for your project. And the accuracy of your data is determined by the kind of project that you are engaging in. And once you collect your data, you need to be able to store it somewhere. So we call these geodatabases. And you're able to store your data in geodatabases so that you can retrieve them. So the geodatabase can be a local disk drive or a cloud storage that is available to you for your use, whether it's managed by you or by an organization. And then you move on to the data management phase, where after storing your data, you're able to check it for errors and be able to correct the spatial and the attribute data. of any errors that are within your data set. For raster images, you may need to perform some atmospheric corrections and all that. So the next stage is the analysis stage. Here you're able to identify patterns and relationships between features in your data set. So you're able to determine the relationship between population and maybe the cost of prices or the cost of goods, products. Yes, you're able to also find the relationship, between the health facility and where people actually live, and find the distance between and the time required to cover, so that in emergency situations you're able to make better decisions and find the shortest route to the health facilities from wherever you live. Then the output of most GIS works is an application and a web map, as I stated earlier. So most of the time you want to come out with a web map or a map itself. Even if it's a paper map, you want to also come out with a web application that is interactive for the user to be able to visualize whatever information that has been gathered through the preceding processes. Right. So this visualization enables the authorities involved or the people involved to be able to make decisions based on the insights that they've gained from the data or the work you've been able to undertake. So moving on to the next stage. So there are several spatial analysis techniques that are available within the field of GIS, but we're going to talk about just a select few of them. So first is the overlay analysis, which integrates spatial data with attribute data. Attribute data being the information about each feature on the map. And overlay analysis does this by combining information from one GIS layer with another GIS layer to derive or infer an attribute for one of the layers. So a typical example is in the field of land use planning. So let's say you have a local government that is planning a new park and needs to consider existing use of land and soil types and population density. So what you can do with overlay analysis is to combine multiple layers such as land use maps, soil type maps, and population density maps. And the intersection of these layers helps identify the most suitable location for the park, and balancing factors like land suitability, minimal impact on existing land uses, and accessibility for the population. Right. So the next is buffer analysis, which basically means creating buffer zones around specific geographic features. It can be a point, it can be a line, it can be a polygon. Create specific distances or buffer distances around them to be able to analyze the features within the zone. So a typical example is identifying areas that are at risk near a river, right? So let's say a city wants to identify these areas that are at risk of flooding near a river. So what you do is to create buffer zones at varying distances, maybe 100 meters, 250 meters, 500 meters, even 1 kilometer if that's what you want, around the river. And these buffer zones help in identifying residential, commercial, and agricultural lands or areas within the potential floodplain. So this facilitates emergency planning and zoning regulations. So you're able to know the features that are within the landmarks that are within or the people that are within the zones that are at risk. So for spatial interpolation, it's basically estimating unknown values at certain locations based on values that have been obtained within that area. So let's say you're estimating rainfall distribution, and you have rainfall data that has been collected from several weather stations within a specific region. So you use the spatial interpolation methods such as Kriging or inverse distance weighting IDW to estimate rainfall values at unsampled locations. That is the locations that you've not collected data from. And this creates a continuous surface of rainfall distribution, which is useful for understanding the precipitation patterns and planning water resources. So popular GIS software and platforms. Once again, there are a lot of GIS platforms that are available, but we're going to just talk about a select few. And ArcGIS is the most notable of them all, I believe. And I think it's followed by QGIS and then MapInfo. ArcGIS, developed by SG, is has a wide range of applications and tools available to users. And whilst it's a commercial platform, it has comprehensive mapping capabilities and spatial analysis capabilities, and you're able to collect data using its mobile apps, and it synchronizes seamlessly with the desktop and with the ArcGIS online cloud-based platform. Then there's QGIS, that is a open source alternative to ArcGIS, and the other commercial GIS software that is equally capable of giving the user most of the tools that are needed to be able to create a map and to be able to um, enhance their GIS skills. So there's also MapInfo that also focuses on business intelligence and marketing analysis, and has several tools that are available to the user to explore. So GIS can be applied across several fields that are in existence in the world today, ranging from healthcare to agriculture to transportation, education, sports, even banking and finance, urban planning, the telecom industry, the oil and gas industry, and even forestry. So as long as there is a spatial location to whatever field you are involved in, GIS can be applied to map out the trends and the patterns and relationships within that field. So ending, let's talk about the future of GIS and how GIS can be maximized in the near future. So, talking about big data integration. So, this process has already started. So, and then we realize that big data integration is revolutionizing the future of GIS by enhancing data analysis and enabling real-time processing and improving decision making through comprehensive and accurate analysis. Right. It facilitates predictive analytics and also gives better data visualization and interdisciplinary applications across several fields such as healthcare, agriculture, transportation. And then also the scalability and flexibility of big data technologies support the growth of GIS systems, whilst the Internet of Things integration provides continuous spatial data from devices that are connected to big data. And um, it also enhances collaboration and data enrichment from diverse sources that further expand GIS capabilities, making it a powerful tool for solving complex problems and driving informed and data-driven decisions, in several industries today. So real-time data processing, as I spoke about earlier in the previous point. So real-time processing is the future of GIS really, because it enables the immediate analysis of large data sets, on the go, and providing timely insights that are essential for critical applications such as disaster management, traffic monitoring, and environmental monitoring. So this capability allows GIS to deliver up-to-date information and thereby facilitating rapid decision making and predictive analytics. So the integration of real-time data from Internet of Things and devices and other sources actually enhances situational awareness and operational efficiency across various fields, including once again healthcare, agriculture, transportation, and so forth. And overall, real-time processing really transforms GIS into a powerful tool for proactive and informed responses to the dynamic challenges we face in our world today. Currently, we are at the point where desktop GIS is the main platform that is being used to access the capabilities of GIS, and you need several high and expensive devices or tools to be able to collect GIS data and all that. As I spoke about earlier, our GIS platform developed by Esri have been able to already integrate the mobile feature or the mobile platform that enables data collection and sharing of geospatial data to other collaborators. So in the near future, mobile GIS is going to be a big thing as it enables the collection, analysis, and sharing of geospatial data in real time from any location at all across the world. And this mobility enhances field data collection, allowing for more accurate and timely data updates directly from the source. It improves decision making by providing the on the go access to spatial information and tools, and thereby supporting various applications such as disaster response, environmental monitoring, and urban planning. And additionally, mobile GIS fosters greater collaboration and data sharing among teams, making geospatial technology more accessible and integrated into our everyday workflows. And therefore, it expands the reach and impact of GIS across multiple sectors that are available to the world today. So, to sum it up, GIS is an incredibly versatile and powerful tool that helps us understand the world around us through the lens of spatial data. And whether you're a professional in the field or just someone curious about the technology, there's always something new to discover in GIS. Thank you for watching. If you found this video helpful, make sure to like, share, and subscribe to ScopeGIS for more tutorials and insights into the world of Geographic Information Systems. See you in the next video. Keep exploring boundaries.